Stars so bright in the sky. On Arizona nights they fly. Nebulae in colors rare. Galaxies beyond compare. Sky tour in the night so clear. Brings the universe near. Real-time wonders to see. Streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds. Stories of the cosmos told. Through the lens, a distant dream. Living real like a gleam. Far away, up so high. Across the stars beyond the skull. Through the lens, a distant dream. Living real like a gleam. Lift your eye up so high. Across the stars beyond the sky. Sky tour shows us the way. Every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new.
Hey, welcome everybody to the SkyTour live stream. Mark and Daryl here with you. Hey Daryl, what's happening?
Hello, Mark. I'm good, thanks. You? Hello, everybody. Not much happening at the moment except for firing this thing off.
No. Tonight's the first night of the stream where we're going to be looking at the comet. And you look at the telescope, you can see it's really leaning over here in the observatory. And so it's already impacting the other wall because the comet's close to the western horizon, but it's about 17 degrees above the horizon, and so that's what we're looking at. But this tail is huge. It's at least 1.5 times this length we see here outside our view, and we can actually just move the telescope a little bit. We're actually doing a 5-second shot, so you won't see any movement right away. So as I move it over, you'll catch it.
The tail is over 10 degrees long in wide field images. I saw maybe 6 degrees last night through the binoculars, maybe 3 degrees naked eye.
Yeah.
It looked great in binoculars.
Yeah, and I was outside earlier tonight. I saw it with my naked eye. I saw like this right here. I didn't really see any of this. But then in a dark sky with averted vision where you look to the side and let the black and white receptors in your eyes pick up the light, you can see a little further out. The limit is basically up to the sensitivity of your eyes and how bright this this tail is here. But that's Comet Tsuchinshan-ATLAS right there. And like I said, if you look here at the wall, this is actually the opposite wall. So we have a 10-inch telescope, 10-inch diameter, and we're actually running with about a 5-inch right now because we're cutting off about half of the diameter of the telescope by leaning way over like this to the west. But in coming days, we will be able to see it higher in the sky. And although it's getting fainter, that won't matter for us because we can still grab it and check it out. This is a live view. It's every 5 seconds. So we're not going to stack, but I mean, I could try a stack and see what we get. So I'll do a 5-second stack right now and see what we get. Okay. So here comes the first one. Hopefully that works. Yeah, and we probably have to get rid of this guy. Yeah, there it is. Yeah, the darkness is getting in there, and I will correct for the color mess we get. That's a little better. Hey, actually, we're stacking. Good. See, it's dark enough for us to stack. We've got 4 now stacked. This is good. And we can actually darken things up and do a little processing. So.
It was interesting looking at it last night. I mean, I was out there. Oh God, I first went out 15 minutes after sunset.
Yeah.
I really didn't pick it up until about 40 minutes after sunset. But before then, I was watching the sky, naked eye and binoculars, and I saw when the very first star came out, I could see Venus over to the south of the comet, along the western horizon. That was obvious. And then Arcturus came out, and I see the anti-tail, Mark.
Yeah, I know. Just pointing that out.
Wow. In the binoculars, I mean, more and more stars started coming out, and bang, I hit the comet, and it was obvious in binoculars. It wasn't obvious to the naked eye at first.
Yeah.
But as it grew darker, it got obvious naked eye, and it looked great in the binoculars.
Wow.
You caught an anti-tail.
There it is. So if you look at this dust tail right here, out behind the comet, you have to remember you're looking at the universe in 3 dimensions, and the dust tail curves. As it goes around the sun, it sort of lags behind the ion tail, which always points directly away from the sun because that's an ion stream blasted off of the comet's surface by in the coma by the solar wind. But this part right here, that little tail segment right there, that is the fan of this swinging dust tail as it goes around the sun, and it curves. And so we're seeing the far side of that curve in 3 dimensions. But see, we're looking at it kind of in the plane of the comet right here, because we're orbiting the sun, and where the comet's placed right now, that's how we're seeing it. So this tail we see here is actually curving through space millions of miles, and out on the back side it's doing this. Let me see if I can make this a little bit brighter. Yeah, there's the anti-tail. So what we're going to do while we have the opportunity is we're going to move this over and see how much of the anti-tail we can see. So first things first, I'm going to call this, in the interest of time, Comet A3, and we know it's going to be Tsuchinshan. All right, Comet A3, just so I don't have to spell it all out. And then we're going to save it, and I'm going to save it with this anti-tail. So I'm going to pull this up a little bit. Okay, now the data is going to save just like it's supposed to. All right, and then we're going to save it exactly as seen so that anti-tail will be visible. Okay.
The anti-tail started showing up a few days ago. It peaked on the night of the 14th, I believe, when it was crispest and brightest, and now we're on the backside of the Earth is basically passing by the orbital plane of the comet.
Yeah.
We're not in the comet's tail, but we're seeing along the plane of it, which makes the anti-tail show up as a line.
So we're gonna. This stream won't be hours like before. We're gonna be doing a little bit less than that. But I'm gonna try and find out how big this anti-tail is. So I'm gonna move us up. I can see it going way, way out here.
Yeah.
Holy cow, that's a big anti-tail. Look at that. All right, I want to see the whole extent. So I'm gonna move to the west of the telescope, and then we'll take a photograph of this side of the comet, and then do a stack in there. That's really nice. Nice. Okay, so let's now go ahead and do a we'll try 10 seconds on this. I was doing 5. We'll try 10 now. We still have sunset light, you know, and so look at the size of that anti-tail though, huh?
Yeah.
Wow. So I'm gonna get out of our low quality, our low light, and go into deep sky mode. All right, we'll clear this last image, and this next image that comes in should be first shot with the anti-tail as a whole.
Inspired has a question for you.
Okay. Oh, it rejected this one. Come on. Let's do this. See if we can just get an image. What's Inspired asking? I'm gonna try and grab us a.
What is the name of the app that you're using? How does this work? My first time here to watch it.
Oh, fantastic! Wow, look at that.
Yeah, wow.
That's the anti-tail, guys. Yeah, I'll answer that question. It's a great question. I'm using several apps, okay? First of all, let's color correct this. There we go. And let's actually darken up and get contrast. And Inspired, I'm going to get to your question, I promise. Wow, look at that. That's beautiful.
Yeah.
That's a beautiful, beautiful anti-tail. All right, so Inspired, this app here is called SharpCap. It is a program that allows us to use filters to help us get the images correct the first time. And that's this guy here. It allows us to do a little processing and so forth. This app over here, this is APT. APT is astrophotography tool. That's what I use. All right. So in general, this is APT. This is the computer. That's a telescope in the building. That's, well, you know who that guy is. This is our stacking screen. We actually take an image sandwich to get rid of all the noise. This is our main view. This is the telescope exposure section. This is the gain section, sensitivity of the sensor, and how long we're going to expose that sensitive sensor. This is another histogram or a processing thing. We can see how much is hiding in there by just clicking on this. Okay, and then down here, this is another telescope control section with focusing data down here. Okay, so that is what we've got running here, and I am actually really liking this anti-tail. That's really pretty, man. Let's see if we can pump that up a little bit. No, this will make it really grossly bright, but we can actually see the extent. I don't believe we've ever seen an anti-tail in the comets we've looked at. The last comet I think we saw was Neowise. We saw Holmes before that.
Yeah. I don't recall seeing an anti-tail here.
Yeah.
I've seen an anti-tail several times.
Sure, okay.
Yakutake had a heck of an anti-tail.
Wow.
The night it passed closest to Earth. It was up near the North Pole that night.
Okay.
And Hale-Bopp had an anti-tail. They tend to be brighter comets that anti-tails become visible.
Okay.
Some comets do, some don't. It's all the angle of the dangle and where Earth is and where the comet's orbital plane is, whether we see an anti-tail or not.
Okay, we're going to say that one again. Okay, so this, we're already, I know we just started the stream, but unfortunately, obviously, we're the telescope is hitting the building a little more I'm gonna clear this and start over and see what we can get. See if we can, because we're doing 10 seconds now. Yeah, see, it doesn't. It's reject. I'm gonna actually turn off our filter, which does our make sure our stars are round, so we'll actually get an image. All right, and then I will let it. Look at that's crazy. It looks like a bullet with a nail sticking out of it.
Yeah.
Okay. Telescope can guide pretty well, but I like to really put it through its paces.
Folks, I don't mean to be rude. We don't have the comet for very long. Save unrelated questions for after the comet goes away, please.
Yeah, which is going to be really soon. If you look over here, I'm going to pull this out just to show you. This is our observatory view right now, and what I'm going to show you by enlarging this here. Okay, the other wall is actually right here. Okay, so you can see that the telescope is hitting the wall, so about half the telescope is being cut off, and that's okay, because sometimes that happens, and we don't really have a choice. Oh, okay, good, nice stuff.
No, it's not an accident that we usually see comets before sunrise or after sunset.
Yeah.
And physical system constraints, you know.
But we check them out, and it's going to get higher and higher in the sky every night. So as the nights wear on, we will have the comet for a lot longer in the sky as we move into later October here, till about maybe the 20th or so. And so, but then it'll be a lot higher in the sky, and so we'll get a chance to observe it for a lot longer.
Yeah.
That looks really weird, doesn't it? It kind of has that weird look to it.
Oh, that's cool. You ought to show that picture someplace.
Yeah, I'm gonna save it, and then save it exactly as seen.
Let's see the whole comet again before it goes away.
Meaning the tail, you mean?
Yes.
Okay, let me back us out.
Folks, I want to say something. I'll try to be brief, Mark.
No, I know what you're gonna say. It's good. Good idea.
And I don't mean to sound preachy, but this is one of those objects you can and should go out and see with your own Mark I eyeballs, if at all possible. If your weather's good, if you have a good view to the west, if not, if there's a good view to the west somewhere close by, it's worth going and actually looking for and looking at the comet. Seeing the real thing is just light years, quantum leap beyond seeing a picture of it.
He's right.
This is the kind of thing you may remember for the rest of your life. I'm serious. I still remember every comet I ever saw. And as Shakespeare said, you know, the skies themselves portend the death of kings. These are always seen as big markers for what's going on in life when great comets pass through. And if you get to see it naked eye, or if you get to see it binocular is a great way to look at the comet right now.
Yeah.
It is something you will never forget. It's like the difference between watching a beautiful sunset and looking at a picture of a sunset. It is just not the same thing.
Yeah, I agree with that.
I will now get off my high horse.
Oh no, that's a fine horse to be on. You're actually encouraging people to explore the wonders of the night sky with their naked eye, like we all have in the beginning.
Absolutely.
There's nothing wrong with that at all. That's a satellite passing through while I'm moving. Okay. So moving slightly to the east brings us a little bit more above the wall. So now I'm going to do another 10-second shot here. All right, and we'll try and live stack this as well. And we'll get out of our low light mode and go into, hello, and clear this out. pretty. All right, and let's see if we can stack here. Let's color correct. All right, color correction worked, and yeah, it's not. I gotta. It won't stack yet. It's hard to stack when you have a fuzzy object like a comet.
You see the color of the dust tail?
Yeah.
That's the color of sunlight. Whenever you see a comet's dust tail in the sky, it's always the color of sunlight.
Right, because that's reflected light. The ion tail is what they call the gas tail, and that's from carbon compounds on the surface of the comet and in the coma of the comet, which is the around the nucleus is that cloud of the stuff that was taken off the comet by the ultraviolet energy of the sun and by the solar wind. And when you see those two things occurring, you'll find that the dust tail is, as Daryl says, is the dust particles raised off the comet's surface by the solar wind and interactions with the comet, which is sublimating, not melting per se, but sublimating. And the gas tail is the ions, usually of some of the compounds on the comet, all carbon-based compounds. So you have cyanogen, which is carbon and a nitrogen. You have carbon-carbon. You have carbon dioxide. You have carbon monoxide, CO. And when carbon monoxide is ionized, you get the ion tail as well. So that's just the ions streaming back, and they will always point away from the sun directly, exactly away from the sun.
And the most important part of that ion tail is it's green. It's very green or blue-green.
Yeah.
And it's beautiful.
Yeah, and that's the cyanogen.
Yeah, you'll see the broad fan of the dust tail, and then you'll see like a thin blue line, which is gas tail, the ion tail. Actually, I'm sure it's there right now. It's just the sky is not really dark yet. If the comet was much higher up in the sky, I bet we could see the ion tail as well.
I think the ion tail is going to be up here, based on where the sun is. Actually, no, it might be right along this line. We might not be able to see it because it might be within the dust tail in terms of the view from our perspective, which does happen. Now we get rid of the color and you can see it in black and white. There, that looks like every astronomy book picture of a comet you've ever seen.
You want to try to catch the anti-tail one more time for the light screen folks?
Yeah, let me see. We can see it right there.
Yeah.
Excuse me, I got a problem with my throat.
Every comet is different, folks. 1996, everybody was getting ready for Hale-Bopp to come later in 96 and in 97, prime time. And Comet Hyakutake came out of nowhere, and by surprise, Hale-Bopp was intrinsically a huge comet, but it wasn't very close. When Hyakutake snuck through, it wasn't a very big comet, but it came very close to Earth. And its appearance was so striking. It looked like a big blue-green spear going halfway across the sky. It was absolutely amazing to see. And the head of the comet had the spearhead shape to it. And then when it was in when we were in its plane that night, you saw that anti-tail, a big spike come out of the front of the head of the comet. It was a very distinct, sharp spike on Hyakutake.
I'm going to go further over on the satellite because I want to try and catch. I want to catch as much of this anti-tail as I can. See if I can find the end of it. And you can see it here, very, very subtly. It's that's about the best way. We'll see maybe a little bit further north here.
Yeah.
As long as you get it down to that diagonal corner, that'll give us as much as possible, and maybe jog to the west and up, put the nucleus right here.
You know, you're losing it to the wall. It looks a lot dimmer than it did before.
Yeah, we're gonna lose a little bit. Well, actually, in this mode, we'll lose a little bit.
You gonna stack it?
Yeah, I'm gonna try. I'm gonna just go back up now. Throw this into 10 seconds again, and I'll go for it. Drop out of this, go into my stack. You'll see the last image we took of it. Again, it's going to get better as time goes on. I've saved that.
You know, the other odd thing about Hyakutake, almost all you saw was gas tail.
Oh, that's interesting. I forgot about that.
Yeah, it didn't show much dust tail at all. Just enough to make the anti-tail when we passed through its plane.
Wow.
But it was just a tremendous big blue-green spear flying across the sky.
Well, we got a beautiful spear flying across the sky right here. This is kind of cool. Yeah, we are quite into the wall, but you'll see the anti-tail again. That's the dust tail. As the comet goes around the sun, as I said, as it goes around the sun, it kind of lags behind fishtails. Effectively, it looks like it's fishtailing, and this is the far side of that dust tail you're looking at right here, farther away and on the curve. So that's the curved part going into the page here, curving around, and this is the nearest part of the dust tail to us. Is this front end goes all the way out there and all the way around, and that's cool. All right, well, we're not going to have much more luck with this tonight.
Carl Becker asked, will these be posted? I assume he means on the server, and I assume...
Yeah, they're already up. They're already up on the server.
Okay, let me put up a link real quick.
Thank you. Now, I know I haven't said hi to anybody, but we had to get going on this because it was really, really quick. But I do want to say hi. We have some new faces tonight. I'm glad you guys joined us. I want to say hi to Tiffany, who joined us first, Tiffany Echo. Tiffany and Mike are the giveaway hosts. They give us equipment to give away. We've given away telescopes and binoculars and more to come. Sam S. is with us. Hi, Sam. We have... Who's that Daryl guy? Stan, Two Rivers Observatory. How you doing? And SkyTour. Who the hell's that? And JSCO's 77, another one of our past winners. And Genghis is with us. How you doing, man? Water Rat, that's Matt. He used to work for me here. He's actually a really, really, really good model maker. And we did models of lots of things. And then we had, let's see, we got new folks here. Rockstar's with us. He's been here before. Rockstar's with us. Raul, how you doing, Raul Babadia? How you doing? Nice to see you. Gary Mogul. Is it Mogul or Mogul? Let me know. Nice to see you. I think you're a first timer. Make sure you guys subscribe, because we look at all the astronomy things, and we stream on most clear nights anyway. And Inspired is with us. Hey, Inspired, nice to see you. And now I have also got to say, let's see here, Roxy NYC. I know Roxy. I'm going to see Roxy actually in just a few days. On the 24th, Roxy's going to come in with her cousin, and they're going to come see a talk at a conference where I'm speaking, and I think that's kind of cool. And I also got invited early this morning, to Nova Scotia to do a talk at the Shag Harbor conference next year. They start early, which I think is really cool. Okay, and then SkyTour Live fan. I love that name. How you doing, man? I think that's Evan. And Ron Regier is with me. Hey, Ron. And you're welcome. He says, thanks for showing this. Yeah, look at this, huh? And we actually stacked 19 of them, so we're good here. I'm going to save that, so we'll have a good image of this right here. Save exactly as seen. All right, so that will be stacked in there.
Go back and see the tail again.
Yeah, let me see if we can stack that. I want to say hi to Jeff Penn. How you doing, Jeff? It'll be in our sky to see. You'll see it for another week or two with your, maybe not with your naked eye, but you will see it with binoculars. Michael Galea is with us. C&D boy, how you doing, man? And Mr. Django's backyard. If you haven't been to his site, you got to check it out. He's really cool. He's got some cool stuff up there. All right, let's get out of this and get back and go back here. I didn't get to the right buddy. Stephen Ireland, how you doing? Oh, I'm glad he says I didn't see the comet in real life, so this is great. Thank you, man. Yeah. You know, when I got my astronomy degree, I decided I wanted to go into public outreach to actually show people the sky. And so that's exactly what we're doing. All right, and let's see. Ron Regier says we would appreciate the elevation angle and heading. Well, the heading is almost directly above the setting sun, okay? And the elevation angle will, of course, vary as the night goes on, but it's usually right after sunset. And right now, it's about 17 degrees and 17 and a half degrees, and then it, of course, goes down to the horizon. But you will actually be able to see it. It'll be higher and higher and higher in the sky, and I think it's going to go to just about 27 degrees before it gets really faint. I have to look that up, make sure. But I think 27 degrees was the logical endpoint for people in general. And that'll be over the next couple weeks. Okay.
If you hold your hand out at arm's length with your fingers together and turn it sideways along the horizon, your hand will subtend about 10 degrees of arc. And last night when I picked the comet up, it was about 20 degrees high in the west-southwest. If you've seen really bright Venus down in the west-southwest, the comet is to the right and now a little above Venus. The comet last night or night before, if you're familiar with the star Arcturus, the comet was right between Venus and Arcturus and a little bit above the line connecting them. Last night it was a little higher and a little closer to Venus. It's going to continue climbing and moving over closer above Venus every night. Not closer to Venus, but, you know, rising diagonally over Venus in the coming days. That's nice.
No.
You see the detail in the nucleus?
Yeah. To see that, I want to actually zoom in on the histogram. It's called this is how I do my immediate processing, and then I do it better in Photoshop. But if I take this and bring it down quite a bit, then we actually knock out a lot of the brightness, and we can start to see a little more of the nucleus. It's still overexposed for the sensitivity of this camera. Let's see how much we can see as I drop this down. Go way over here. Yeah, see, that's saturated right there.
Yeah.
So it won't get much smaller than that. And that's not the size of the comet nucleus. The comet nucleus is only a few kilometers across, if that. I'm not sure what the estimate is. Maybe it's 3 to 6 kilometers. I do not know. I don't know that they've published that yet. Maybe they have.
Say that again.
Diameter of the actual nucleus. I don't have that.
I don't know.
Okay, let's bring this up and do this. Darken the background a little bit. That's too much.
I'm getting excited here. My point a moment ago was, since your hand is about 10 degrees wide at arm's length,
yeah,
2 hands high above the west-southwestern horizon should put you close enough to the comet to be able to pick it up.
That's right. I actually used the hand analogy to find it relative to Venus.
Mm-hmm.
Yeah, we're right in the wall. I mean, right now this is the wall right here. We're in the equivalent of maybe a 4-inch telescope right now. Now this red you're seeing here, this red is not the sunset red anymore. That's actually the red of something else, which is really interesting. On the end of the telescope, the camera's on the end of the telescope here. You can't see it inside this round barrel. And in there is a tiny red LED. But the camera's very sensitive, and that red LED is shining an absolutely imperceptible light several feet away on this wall, and it's picking it up. That's what this red is. A very sensitive camera. So fascinating. It's really cool. Daisy and Zoe are with us. Hi guys, how are you? You may want to play this stream back to check it out later and see the earlier images of that comet. And here is Ronald, Earth Radio. Hein Cherry's with us. How you doing, Hein? Nice to see you. Or Hein. I need a nice I'd like to have a nice pronunciation of your name. And then who's this? We got PJC West, Pick West, PJC West, I think. Comets are electric phenomena. Well, comets are of course loaded with charged particles, no doubt. That's for sure. Yeah, Steve in Ireland says, "Can you turn off the red LED?" You probably weren't asking that like that. When I go out I'll be out there. I'm leaving on the 30th to go out there to do maintenance, and I'm probably going to put a black cover over that tiny LED. I mean, it's small. It's the size of the head of a pin, but it's more than enough to be picked up by this camera. So this will get better as the days go on, by the way, and so we'll have fun with this. Wow, we actually stacked 24. That's pretty good. I'll be able to correct the colors and the gradients you see. We'll be able to do that. So we'll save exactly a scene. All right, but we're running out of visibility here. But hey, I'm sticking with it. Sticking with it until it doesn't work anymore. Now, I'm saving these. You'll see me saving, and you'll see that it gets saved. And so here is the actual file that's saved up on the server. This here, you can go get that right now. It's actually up there already. And our server is, you can find it at skytourlive.org right here. Okay. We are a non-profit organization. We definitely could use some help if you guys are of a mind to donating. You can go there and donate. You can also, you don't have to, you can also join our Patreon if you like. And I think it would, like I said, very helpful, because we are moving this telescope and our new telescope we got. This is a wide field scope, and we got a narrow field scope that's higher power that we're going to be using. Where'd it go? Did I clear it? Oh no, okay. Interesting how that happened. And okay, stack saved and auto reset. There's an auto reset on this. I will have to. Oh, okay. I gotta take that auto reset up. I discovered that I opened this up one day and it was all reset to defaults, and I had to go through last night actually and put it all back in. So I did, and now except for that one I'd missed, so we're good now.
Carl Becker has a question of you.
Okay, where's Carl? Carl says, in the last upload of the server there is a white line due to a satellite. Is there any way for to reload the image and remove one of the... Actually, Carl, I'm doing an automatic stack right here. So you're seeing the stack result as we see it on the screen, and you're right. There is a white line in that one that was here. Okay. And we're about to invest in more server space. So what I can do is, like right now, you see where it says raw frames, save none? I'm just saving the stack. But what I'm going to end up doing is save all. And that's going to allow us to save the individual frames, and then do exactly what you're saying. We can still do everything we're doing here, but we'll actually have a lot more space taken up on the server with the raw data. And so we're going to have the raw data available, and we just have to budget our pennies on this, because we need, like I said, we need some support to do that, and we don't have enough right now to actually buy the extra server space. You know, we're not making any money on this. This is all, everything gets turned back into this stuff to show you what's going on. Okay, I'm going to clear this now. And let's go and look at this. That's our stellarium view. You'll notice how close the comet is to the horizon. It's literally, oh gosh, is that? I think we're at, let me move over a little bit. Yeah, we're actually just about 10 degrees, about actually 8 degrees. Let me look here.
Hey, your other telescope view came back.
Yeah, because the stack, I think I hit clear, but I didn't.
No, I mean the two images over on the left side. Remember?
Oh yes, this guy.
Yeah, he came back.
Yeah. And there's an example of the satellite. These are Starlink satellites coming through here. Hey, Carl, thank you, man. That's really kind. Carl Becker, man. Class act. Thank you, brother. That's very kind. Yeah, we'll be looking at this more and more as we go. Hey, Proficient, how are you? Yeah, it was a great day. I couldn't wait till tonight so I could do this. You'll notice this anti-tail here. This is the dust tail, and the dust tail's curved, as I said, so the swinging around the backside, we're actually seeing the backside of the dust tail. Because remember, we're looking at the universe in 3D here. Pretty cool. We're like way into the wall here, so we're not really getting a fair view of the comet today, right now. But we will, as the days pass. A couple more days from now, it'll be even higher in the sky. We'll be able to check it out. So what I'm going to do is hop out of this and go into our low light view. Okay, look at that tail. That's beautiful. Wow.
I'm surprised you can still see it.
Yeah, we have the equivalent of about a 1-inch telescope right now looking at it. You know? Let's go see here. Yeah, we're actually, it's actually quite low. And this red box is our field, and I moved it over to the right so you can see that STLS here, this is our where the telescope is currently pointing, and then the comet's on the right side of the field. So as with this, okay, comet is, or we're looking here, but the comet's on the right side of the field, so it's exactly a correct representation. Okay, I installed the Comet on the app so we can actually see it. Here is the ion tail. It looks like it's kind of mixed in with the dust tail. This is not the actual ion tail, but based on the geometry and the fact that we see the curve sweeping around right in front of the nucleus like that anti-tail, that tells us that the blue ion tail is going to be farther out, but right in line with the dust tail. So we may not see it until the comet gets a little up and farther away, so we can look up underneath and see that ion tail.
Yeah.
So we have to wait for the geometry to change of the orbit right now.
If that's accurate, it is offset a little bit.
Yeah, but this is just a generic comet image, I think.
Well, okay.
Hey, Truth Seeker.
It's not unusual to see the gas tail offset from the dust tail.
No, not at all. It's pointing directly away from the sun,
Yeah.
and this guy is swinging around, and we see the anti-tail over here. You know, so it's right here. It's like, just to think of it as doing a circle into the page. You know, it's going further away, further away, further away, further away, further away, and then we see the end of it way out here somewhere. That's the dust tail hooking around the sun. You know.
Yeah. Hale Bopp in '97, the gas tail was quite distinct from the dust tail.
Yeah.
They were separated by a bit. Again, the dust tail was a big, broad fan color of sunlight, and the ion tail was a very distinct blue color.
Yeah. Well, so is tonight's on the total loss. Let's go check this out. This is a beautiful big globular cluster. Say goodnight to the comet. It's actually well behind our wall. You can see the telescope now is moving around, and it's going to bring in our fuzzy little counterpart here, this beautiful object here. There it is. That's actually one of them. It's actually down to the lower left. So I'm going to actually now just do something called a plate solve and synchronize. Okay, so now our telescope is now synced with the center of the field, 1825.57, and then it's going to do this and move over. Okay. All right, that globular cluster is not the one we're looking at. I'll show you what that is in a minute. Let's do an annotation. I'll show you what that one is. Okay, and we do a nearby solution here. And
What do you mean?
Well, I'm saying this is measure 28. It's not measure 22.
Oh.
Okay.
Hey, it's a globular cluster, though.
Oh, yeah. Yeah, but it's near measure 22. I just have to bring that in. Okay. Yeah, we can annotate, too, which is kind of cool with this application. You know, and it's actually pretty accurate. So what I'll do is I'm going to go out here. And now I'm going to tell it to go to measure 22 again. But it's actually got the wrong one, I think. Oh, no. I was in the wrong one. I went to the right one, and I told to go to the wrong one. Okay, so now I'll get it to the right one. Okay, but it's a good thing. Here is a globular cluster, right? You see how small it is? Now watch. We're going to go to another of the same type of object. All right? And it has a very different look. Every one of these does. So that's one globular cluster. And then you'll see another bigger one. We'll look at that guy. All right, this one is a bigger one. Why is it bigger? Because it's closer to us. These are halo objects that orbit the galaxy. They plunge through the disk and plunge back up. But this is a really, really beautiful object. And I'll do a stack here in just a sec. I just want to zoom in and check the focus. Looks like we could use a little critical focus here. So I'm going to do a critical focus. This application will also autofocus for us. Saves me a lot of trouble. Yeah. So right now, we'll try this. And now I'll go back one level here. Okay.
Have you made any plans on the changes you'll have to make to shoot through the C11 long focus? YouTube's been offering me videos lately on long focal length astrophotography, and I've watched some of them, and it's really interesting how different it is in some ways from what you're presently doing.
Mm-hmm.
Plus planetary astrophotography, that's a whole different bird altogether.
Yeah, I've been looking at the planetary stuff because we want to be able to see features on the surface of Mars,
Yeah.
a lot of detail within Jupiter and Saturn. And to do that requires a whole different approach to how we're going to photograph things. Nice thing is, this application can do all of that. And it has special accommodations for planetary photography versus stellar photography. So makes it easier for me. I can do it all manually. I mean, I have for years, but I think that this application written by Robin, who is a great guy, will probably serve us well for some time to come. And it even hooks up to the Green Swamp server, which is the server that's going to operate the Celestron 11. This is a Meade 10-inch. Okay, there's our focus, the bottom of the parabola. That's a very important location because that tells us where our focal point is. And so now I can just click best focus, and now you'll watch the focus shift and go back and forth. And finally realign with that bottommost point. Here we go. And now you'll see our stars momentarily now go into pinpoints. Look at that. And now you see down here we have 107 stars. So that's quite a lot of stars. Alright, so now let's check out, even with a full moon, we can do this. We're going to do a 15-second shot. That's 15,000 milliseconds, which is why I put that in there, is 15,000. I could also say 15S. Alright, and so now we'll go into our live stack, get rid of our last, get rid of the low light mode. Alright, and then we'll be here. And down here on the lower right, you can see the progress bar. 2, 1, okay, 0, and then boom, it's gonna go in, and and there we go. Now we have our first shot taken of this globular cluster, and we'll get rid of some of the noise. We'll actually take care of the colors, and we're gonna make a adjustment here, a little processing, get a little brighter. Okay. Now when the moon's out, it just brightens every image anyone takes, and serious astronomers don't take pictures when the moon's out unless they're photographing the moon. Okay. Well, what I like to do is bring everybody in and show them what's going on whenever I can. Alright, so let me back out of this a little bit. You'll notice it looks a little fuzzy and blocky. That's because we have noise in here. There's noise in this area. Okay, you'll see that we have four images stacked. That means that we take a second, align it with the first, and literally lay it on top, and we just make an image sandwich. And we'll do 20, 30, 100 sometimes images. And what that does for us is it allows us to suppress a lot of this noise in between, and eventually it just looks like a stunning image. Alright, and we can actually force it by doing something like this. Okay, but that if we get past the top of our curve, we're losing data, because we really realistically want to be just to the left of that peak. That white curve is the average of the red, the green, and the blue curves. Okay, and if I color correct, you'll see the subtle changes take place if the color curve changes like you just saw. There it is. Measure 22 is beautiful. Daryl said a number of times that, you know, every globular cluster looks a little different, and they have like a personality of their own, and we see that for this one too.
We see sort of a dark leaning bar on the left side and one on the right side, like two legs of a triangle almost.
This guy and this guy.
Yeah, to either side of the center of the cluster.
Then we got this one right here. Yeah.
So why aren't you just to the left of the top of the curve?
Oh, only because with the moon out, if I go just to the left of the top of the curve, then it's going to do that.
Okay.
That's all. It just makes it a little bright. Which is fine. And another way to help get rid of noise is to drag our mid-level. See, these are levels we're playing with. Drag it down about halfway, and then you get that. And so that kind of looks better. All right. And then now we can support having this just to the left of the curve. but it does get a little bit dimmer. But this haze you see here, that's the full moon. But we can still photograph things during the full moon. That's really cool. Catherine Mesick is with us. Hi, Catherine. How are you? Judy M is with us. Hi, Judy. Very nice.
This is another of the first deep sky objects I ever saw.
Oh, wow. We'll call this Measure 22, which is what it is, and it's a capital G, capital C, capital G, capital C globular cluster. And we'll save it, and save it exactly as seen. And one of the things I like to do, folks, is I like to push the system to see what we get, even with the brightest skies with the moon. And I'm surprised sometimes at how good the images look, but compared to no moon in the sky, there's no comparison. But that's okay. So this is pretty cool. These have hundreds of thousands of stars in them. And the thing about these globular clusters, being, as I said, they're orbiting the galaxy as a whole, okay, is the interesting fact that they are among the oldest objects in the universe. And the stars in them are called population 2 stars. Now, you would think older is 1 or 0, right? Population 0, population 1, population 2. But no, we astronomers love to confuse you. Population 2 are the older stars, and those particular stars, when we look at their chemistry, we look at their spectra, we break the light up into the rainbow of colors, we can see lines in the spectrum called absorption lines, and they tell us what elements are actually doing the absorbing, because you see elements will absorb certain amounts of energy and you get a dark line. So hydrogen absorbs a bunch of lines, calcium absorbs 2 primary lines, sodium absorbs lines. But when we look at these stars, their spectra are remarkably clean and they don't have any real contamination by anything. This tells us that these stars were amongst the first stars created in the universe. And so they're stars that are so old they don't have any other materials in them because they formed before there were any other materials. Many of these stars out here were formed after the universe has been around for a while and after stars have gone supernova and blown their guts out to the universe, filling it with calcium, phosphorus, magnesium, iron, silicon, etc., etc., etc. from the periodic table, because stars are the element factories that make it. So if we don't see any, that means that the star is rather pristine, and it means that it was formed where there was none of those materials. Well, our sun was formed in a solar nebula, as we call it, and we have planets around our sun because of the fact that there was so much of this other material already in that solar nebula, the primordial cloud from which all life and planets sprung in our solar system. Well, that genesis of planets and stars came at a cost. When you look at the sun, our sun is filled with these lines. When it was made, it had all kinds of elements in its outer atmosphere. Fusion only occurs in the very center of a star. All the rest is along for the ride, and it's full of all this other chemistry that we see when we look at the star's spectrum. So that said, the spectrum of the star tells us many things. Our new telescope will have a spectral analyzer on it that will be able to look at the stars and see all the stuff, like all those lines in the star's spectrum. We'll see them, you'll see them right on the screen, and we'll be able to identify stars based on these lines. So that's next with the new telescope. All right, and that's a Celestron 11. This is a Meade 10-inch. So 1 inch doesn't make that much difference, but it's going to be a telescope that doesn't have a wide field system on it like this one does here. Okay, this is a wide field system. Our field of view is 1.5 degrees by 1 degree tall with this new camera we've got on it. So it's really something. But we're going to have the ability to do other things with the new telescope. We're going to use something called a filter wheel, and we're going to rotate different filters through. We're going to be able to do very fancy. We're going to do very fancy stuff, with that, and we're going to have the ability to do the spectral analysis, and we'll have a filter like we're using for this to see this stuff. So it's a lot we're going to be able to do. Our colors are off a little bit. Cosmic Ray is pointing that out. And that's only because we're not actually able to see in the proper color rendering right now. Actually, a better color rendering is like this. Okay. But, we have the moon out, and that affects how our camera color is actually seen. Okay, well, I'm glad we got to show you the comet, guys. That was cool. As the night goes on, as the days go by, we'll be able to look at the comet in more detail because it's going to be higher in the sky, and we'll be able to see that anti-tail as well, Daryl. Hopefully that'll still be there.
Hopefully. It does tend to go away after we pass the plane.
Yeah.
Eventually.
Well, we'll see it go away. But the anti-tail is really, really nice. It looks like it's substantially long. All right, guys. Oh, look. Again, I mentioned it before. This was going to be a short stream. It's just a Comet Tsuchinshan-ATLAS stream. And we threw in a couple extra little goodies for you to see as well. And Daryl, of course, thank you for putting up the locations. If people want to know where to find us, you can go to skytourlive.org. Skytourlive.org is our 501c3 nonprofit organization. None of us are making any money. And that, if you go there, you can go to the upper right and go to our Patreon, join that. You can hit donate and just donate if you feel like donating. And you can go to SkyTour Radio, our radio show on astronomy, Sunday nights, 6 to 8 on KGRA out of Ogden, Utah. You can see on our YouTube channel, SkyTour Livestream, you can see up, I think I've got about 450 streams up there. And many of them are minimally 3 hours long. Daryl knows, he's sat through most of them. So, and Stephen Ireland says, I learned something new tonight. That's cool. Very good. Hey, D. Smith, where have you been? Nice to see you. But anyway, I hope you guys had a good time. And Ronald has one last question. He says, when was the first time the comet was spotted? I'll bet you know that, Daryl. I
already answered him.
Oh, you did? Okay.
Yeah, 2023. That's what they call it. C 2023 A3.
All right.
That's its scientific designation.
Yeah. C/.
And Tsuchinshan means Purple Mountain Observatory. They were the co-discoverers with in China, Purple Mountain Observatory.
Very cool.
They co-discovered the comet with the Atlas project.
Very nice. Very nice. I also want to let you know that SkyTour Livestream has been selected to work with Las Cumbres observatories, which are a network of professional observatories around the world. And we are going to be investigating exoplanets on Barnard's Star and around Mu Cephei, which is called the Garnet Star.
Oops, what
happened?
That loud noise I made.
Oh, okay, that wasn't a big deal. Right.
That was a coffee mug noise. Teacup noise.
So the bottom line is we're trying to make strides in the astronomy world as well. with research for planets in astronomy. Exoplanets are my strong suit. That's what I was most interested in. That's what I wrote my book about, the populated universe, and it talks about the formation of life in the universe, etc. The book's available around the world in Amazon and everything if you want to check it out. Either way, I hope you guys had a good time. I'm gonna save this one more time because it's here, and then we'll head on out. This was a very short stream, one of the shortest we've ever done. Normally we go for many hours, but with the moon out, I generally don't stream, but because the comet's here, I have to stream. It's got to, because you guys have to see this thing. You saw it, and that anti-tail was spectacular, Daryl.
Yeah, I'm glad we got to see that.
Yeah. Okay, well, you guys, you have a good night, and we will be back the next time it's clear, and if that's tomorrow, that'll be tomorrow. All right. Now, I'm in Connecticut, and I'm running the telescope 2,500 miles away out in Arizona. So that building right there with that telescope is 2,500 miles away from me. Oh, and one last thing to show you is that we actually have an all-sky camera, and our all-sky camera shows the comet, and the moon is out right now, so this is actually quite bright, and so if I reduce the exposure, you'll see it, but the comet's right here on the western horizon, probably very, very low to the horizon. In fact, the other night I only saw was the tail sticking up off the horizon. The nucleus was already set. So we get to see that too. And the all-sky camera allows us to overlay a constellation view. Okay, so we can overlay the constellations and see. With the moon being so bright, it's really hard to see all this. But I know how to show you. We come in here. These are our nightly time lapses that we do. And let's see. This is sunrise. Let's go to sunset. This is last night. And let's go here. Ah, look at that. There's the comet right there. See that, guys? There's the comet. That's nice. So we can actually watch the comet moving toward the horizon, of course, as the Earth is rotating out from under it. And the comet tail was sticking up when I looked at it at one point last night, but I knew the all-sky was going to catch it. The streaks that go by every now and then are satellites and like that, and planes and some meteors. But there you go. So we can actually do some cool things with this all-sky setup. I built the all-sky camera, oh gosh, several months ago, and put it in a housing and then set it out there. The software is Thomas Jaquin's all-sky project. Very cool. But there you go. All right, guys. You have a good night, and we will talk on the other side, probably tomorrow. See you guys.
Good night, everybody.
Good night, folks.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream. Live it real, like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky Tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky Tour is bringing the views, every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky Tour is bringing the views, every